Hello everyone, and welcome to this introduction module to the Procedural Asset Production Masterclass. In this video, I want to expand a bit further upon the topic of attributes that we discussed in the last video, and I want to show you some of the more common or useful attribute nodes present in Houdini SOPs. Now let's have a look at the scene. Okay, so I quickly want to go over a couple of the nodes in Houdini that manipulate and create attributes. And I think it's good for you to know some of these. Now there are a lot of nodes in Houdini that manipulate attributes. In fact, if we just look under the attributes tab, we can see, well, about 24 or so of them. If we look further down the list under materials, we can find nodes that manipulate UVs, and even further down, well, we find the utilities where we have the point wrangle and the point VOP. These ones are particularly powerful, so let's not go over all of those. Instead, I want to focus on a select few and quickly explain to you how they work with some examples. So up top here we have some nodes in Houdini that manipulate some native attributes such as the point position, but also the color and the normal. And the first one here is the transform node. So the transform node transforms the points based on a pivot and a transformation matrix. Let me grab the parameters panel from up here. And if I just grab my manipulator and I start moving this grid around, you can see how the point positions actually change as well. Let me just hide that. Here we go. Now what we can also do is we can set the pivot on this object somewhere else, and then the object will rotate around that. So the transform node is pretty powerful in this sense, and this rotation and transformation matrix allows me to do this. This is the parameter version of a X form or transformation attribute. Now, I don't want to go too deep into this particular can of worms right now, because this actually deals with matrix transformations. That's a whole other subject. But if we look at the bottom of the transform node, we can see we have the output attribute X form option. And if we turn this on and we look under the detail attributes on this node, then we get a list of different transformations that this transform node has applied onto our geometry. And this is based on the parameters that we've set up here and its pivot location. So basically the X-form attribute allows us to record our transformations so we can use them elsewhere down in our network. Now if we want to go a little bit simpler, we can also use the transform axis node. And the transform axis SOP simply transfers the input geometry relative to a specific axis. So in this case, I have an axis that I can set. And in this case, if I want to rotate on the x-axis, I just have to specify that. And then I can use the rotate channel here to rotate only on this axis. And I can still scale as well along the same axis. So this way I can manipulate my geometry in a very particular way using a very simple transform SOP. Next we have the edit node, and the edit node is a node that automatically gets created whenever we try to manipulate our geometry. So if I actually grab my grid here and I grab some points on it, I can start dragging them around. And when I do this, the changes get recorded in the edit SOP over here. Now if I change my grid, however, then my changes aren't carried over, right? They're basically applied to the point numbers. So you have to keep that in mind, that if you change the original geometry, then the edit SOP will not come along, and whatever changes you've made by hand will be destroyed. This is not a good node to put inside of a procedural system, but it can be useful if you need to move a couple points around or make manual edits for whatever reason. Next we have the peak node, and the peak node allows us to take the normals on an object and then move whatever points we have along them. So in this case the normals are all pointing outwards on the sphere, and if I move the peak value, then it expands or contracts the sphere accordingly. Now you can see that I don't have a help card here, and that's basically a reminder for myself, because I got a lot of these nodes I have here from the help cards. And that means that if you click on a node and you press the question mark button, then you will get the help card for that node. So here we can see that the peak node moves primitive points and edges along their normals. So I'm just going to copy this and stick it in here. In general, you can find all the information about a node in the help card. So yeah, do be sure to check it out. It's very useful. You can also find example files in here as well. Now the mountain node we've already checked out. This one simply moves objects along their normal. So we can apply all kinds of noises to this. Say for example, we grab this grid and we increase the resolution a bit. Then we can apply different kinds of noises to it. Let's say we apply this whirling noise, or maybe, where is it? Simplex. And then we can change the resolution. We can move it along with a time value. So here we have some waves, or maybe deforming the mountains, right? Then next we have the color node. This one applies a color based on a certain setting. So we can apply a constant color. We can apply a random color based on the point number, or based on an attribute, or based on the bounding box, etc. So it's a very useful node if you just want to apply a quick color attribute to your geometry. And finally here we have the normal node, and this one computes the surface normal attribute. So by default, geometry in Houdini does have normals, but this one allows you to recompute them and store them as either a vertex normal. We can store it as point normals over here, or primitive normals if we want to. So this allows us access to these normals as attributes. Moving further down, there's also various ways to create custom attributes. Now we already looked at the attribute create node, and we've seen that if we go ahead and set up an attribute, we can give it a value. We can change how many entries of this attribute we get. So in this case we have 3 values on one attribute, and we can set those individually. But this is constant over the entire object, right? So in this case this would apply to everything unless we filter it out with a group. Now the next one is the attribute noise, and this one allows us to apply an attribute to all the points on our geometry, or potentially the primitives or any other element. And let's say we apply this instead to the color channel, CD. And now we're getting a random color that we can, randomize. If I change some of the values, like the offset here, then the noise pattern gets moved. So this is very similar to the mountain node, except it can be applied to any attribute directly. Then we have the attribute paint, and the attribute paint allows us to use a paintbrush similar to the edit node. It allows us to make manual edits to our geometry. In this case I'm literally painting an attribute over here. Now we can use these controls to change the brush. In general this is a manual node, so this might be useful if you need to paint something on your geometry like a mask as an input. But using this inside of your tool, there's some hoops you can jump through to make it interactive within the tool, but yeah, this will be a manual approach, not a procedural approach, right? For that we need to use some different nodes. Then this next one over allows us to load a texture map. So the attribute from map node allows us to sample a texture map for information to the point attribute. So in this case I'm loading the color values of this texture here into the CD channel, so the color channel. But we can also load it into, say, a single float value as a value called height, and then over here we get the height value output as well. This is pretty useful if you need to load, say, a height map, for example, and store it as a height value. Then next we have here the measure node. Now the measure node allows us to see all kinds of attributes on our geometry and calculate them out. So in this case, I'm calculating out the curvature on this pig head. If I'm going in here and let's say I grab the curvature attribute and visualize it, then now we can see that the curvature, the places where there's a lot of curvature, are more pink, and the places where there's not a lot of curvature are blue. Now we can actually turn on a visualizer on this node here with the color mapping system, but we can also use a different node to grab this. So let's say I grab a color node, plug it in behind, let's set it to a ramp from attribute, and I'm going to use curvature. And I do have to remove my visualizer. And you can see how it's actually represented as a black and white value on the mesh. Now I am viewing a texture, so let me get rid of the texture. And here we go. This is pretty interesting. We basically get a, how do you call that? A cavity map out of this. We can also calculate other things quickly, so we can grab the area per face. And this basically means that if we calculate this out under the primitives, we get the total area of every single primitive on this mesh. So we can see that as a value here. Or we can grab, say, the perimeter for every single line on this mesh. So if we turn this into a line or a polyline based mesh, then every one of these lines would have a particular length to them. So the measure nodes are very useful. We can use it for all kinds of purposes to quickly get information. But let's move on, because we'll be using this later in the class anyway. So we'll cover it more, right? More in depth. Next one's the connectivity SOP. And this one writes a unique attribute based on the connectivity of the elements in it. So here I have 3 objects being loaded, and they're all separated from one another. Now the connectivity SOP will simply grab a unique attribute for each one of them. So I press D, and I just quickly grab my class attribute here, which is the default attribute this node writes out to. And you can see each one has its own unique attribute, and therefore its own unique color representation in the visualizer. Moving further down, we have some nodes that can manipulate attributes. These are pretty useful. For example, here we have the attribute delete. Now here I have a grid with a random noise on it. And if I plug this grid into the attribute delete, I can, for example, remove the color attribute from it. So you could see how on this node originally I have both a color attribute and a height attribute. I probably want to set this height attribute to be just a single float value. There we go. Now with the attribute delete node, I can delete whatever attribute I want. I can delete the color value, I can delete the height value, I can delete every single value with an asterisk symbol, or I could say asterisk and then an exception for, say, just the height value. So I delete every single point attribute except the height attribute. Then next we have the attribute rename. As the name implies, we can rename our attributes. So in this case, I can try to rename an attribute. Just don't try to rename the point attribute. It won't work. But we could say grab the color attribute. And now it gets remapped to, well, something other. This other attribute here. Next we have the attribute promote. Now the attribute promote simply grabs whatever attribute we feed it and promotes it to its neighbors. So in this case we have our points, and each of these points has an attribute value on it, and this attribute promote is promoting it to its neighbor. So in this case we are grabbing the maximum value for every primitive by sampling all of its neighbors. We can also go ahead and grab the average, or we can grab the sum. So this will add them all together and make it pretty bright, in fact, because it's probably blowing it up over yeah, it's blowing it over a value of 1. So this entire mesh is pretty bright. So we can use this in all kinds of ways to control our attributes, right? Next, we have the attribute remap. Now, the attribute remap node allows us to, in a relatively simple way, get an attribute and remap it between different values. So in this case, I'm remapping my height attribute coming from one of these noise nodes here, and I'm visualizing it using a color node. And if I grab my range for, say, the output, I can reduce the brightest color, the highest value, down to, say, 0.1. So you can see now it's remapped the entire color range to a maximum of 0.1. Oh, sorry, the height range. I'm only affecting the height range here. Likewise, we can also use this curve here to manipulate the way how it's distributed. So we can redistribute it based on a curve. We can even set up the curvature on that. So let's say, create a bit more of a smooth transition, like that. But yeah, moving on. Next, we have the attribute blur. This one allows us to blur our attributes, either the point position or the color. Now, if we don't pin the borders, then it will also collapse our mesh if we apply this to the point position. But let's say we apply it to the color instead. And now you can see that, well, our color has gotten really, really blurred out. So let's just reduce this value down a lot. You can see how we can control how much it actually blurs, right? And the step size as well. So this way we can take attributes and sort of smear them out over our meshes. And the last one here is the attribute swap. And this one allows us to swap two values. Now in here, in this case, I am taking my color attribute and my height attribute and I'm swapping their positions. Now the color attribute is a vector and the height attribute is a float. If I swap them, then now it will make the color value into a float and the height value into a vector, which is probably not something you want to do per se, but it's there if you need it, right? It's a quick way to remap, rechange around your attributes. So this next set here is geometry nodes that actually manipulate the geometry, but can also affect the attributes as well, because when a geometry node changes your geometry, it will, for example, remove points, or it will regenerate your geometry, and in doing so, it affects the attributes on those points or primitives as well. So the top one here is a fuse node. Now the fuse node takes the point position of the objects, and based on their proximity, will fuse them together. Now it will try to average initially their point positions. So if I increase this really high, eventually they will collapse towards their original center position, or at least as much as possible. But if I change the basic value here for the output position, and I change this to say maximum value, then we see how the points get collapsed more and more towards the positive XYZ coordinate. So this is a way to control which direction the fuse node works in. But we can also use this to change other values, like for example the color. Now by default it will try to merge the attributes when it fuses points based on the first point number that it uses to fuse any collection of points. But we can also change this to say the average. So in this case, if I fuse them, then now the points will be more averaged out than they originally were. Their color specifically, right? It will blend them together. We can also grab the maximum value or the minimum value of any of the channels here, and so forth. So it's very similar to the attribute promote, except it happens when the points are fused. Next we have the resample node. And the resample node, for this I'm going to quickly darken my background. I'm going to do this in the D menu. And in this case, when we grab a curve, in this case this curve, and I'm applying a random color to it, then if I grab the resample node, it will resample the curve and add new points in between. And what it's done is it's basically taken the point colors on each of the original corners on this curve, and it's distributed it in between these points. So the resample node does this in order to make sure that it maintains the colors. But if I resample it way larger than the original curve, it will still try to do this. So yeah, it tries to average out between the original points and the new resample points. We'll look more into the resample node in the main foundation lecture, but for now let's move on. And then this next node here is the ray node. And the ray node casts rays. It's basically a ray casting node. And it can output a lot of information about what it actually has hit. In this case, I am simply casting rays from a plane up here downwards onto this toy, which has a color, point color. And wherever it actually hits, we can either transform the point position, so we grab the point position from the hit location, or we can grab an attribute from it. Now right now I am copying the point attributes, all of them, but we can also grab other attributes like the primitive attribute from any primitive on this mesh that we have hit, or we can even grab its UVW coordinates, which is a particular coordinate on each of these primitive spaces on the mesh, and then we can use that to grab attributes from that as well. We'll cover more about this later on in the masterclass when we get to this UVW coordinate system. But for now, let's say that this is good enough, and let's have a look at the next section. So here we have the attribute transfer SOPs, and these ones are used to transfer attributes from one node to another. Similar to how the ray node would do it, but in this case it uses either the point number or the distance between two objects. So the first one here is the attribute transfer. And the attribute transfer allows us to take two meshes, and then we're just going to change my color back to light for this. And one of these meshes is red, has red color attributes, and the other one is yellow, and then our sphere is blue. So what's happening here is the attribute transfer is grabbing attributes from the second input and applying it to whatever is in the first input based on a distance, and then a sort of a blending value range. So I can say I want to sample the amount of points I have, and in this case there's not much to sample, but the moment I increase my blending distance and I start to increase my sample range, you see how it tries to blend more and more. That's because it uses more samples to try and get a more even distribution. So in this case it's replaced pretty much all of my blue colors altogether, because it's grabbed the colors from these two and sort of smushed them together as much as it can. Now the model in which it blends can be set up here, so you can control the different ways how it tries to average them out, or you can go ahead and use blend with. And if we reduce the range, then you can see instead of it being a harsh value, it actually blends with the original value, so we can create a more seamless gradual transition between all the different values, both the original color as well as the ones coming from these two sides. So there's a lot of stuff to unpack here, but again, we'll cover this more in the course. And then the next node here is the attribute copy. And the attribute copy copies attributes between different groups of vertices, points, or primitives, and then by the point number or a unique attribute, it can match those numbers, those attribute values. So in this case, I have, let's see, I have two cubes, and I have to actually move them out of each other so we can see them. And one cube's red and one cube's blue. But also, these cubes have a value. One has a value of 1, and the other one has a value of 2. Now over here I have a grid, and this grid is also being assigned a value, in this case value 1. So if I use the attribute copy, based on the value that's present on my grid, I can sample from either one of the sources by changing the value. If I change it to 1, it samples from this object, which is the red box. If I change it to 2, it samples it from the other box. And if these values are kind of distributed along my grid, so let's say I grab some random selection of points in here, like say 0 to 10, and I set this to 1, I have to plug it in behind. And now you can see that it's actually copying from both based on this attribute. So let's go ahead and visualize this. Let's grab this value here, and I'm visualizing it as markers. So we can see how values 1 are marked red and values 2 are marked blue. That's pretty useful. It's also a bit more efficient than, say, the attribute transfer, because it just transfers between 2 point sets, and also it can actually be compiled, but we won't go into compiling right now. Now next I have these 3 nodes, and I don't use these too much myself, but they can be useful. The first one here interpolates based on a nearest proximity point from the second input and sends it to the first input, and it allows us to sample values inside geometry based on its UVW coordinates. Now I'm not going to go too far into this right now, but you can check out the info card on this one. It can be useful. We have the attribute mirror node, and it basically copies or flips attributes from one side of a copy plane to the other. So if you have a mesh with attributes on one side and it's similar on the other side, you can use this to copy it from one side to the other. And this last one here allows us to composite attributes together based on a weight value. So we can plug multiple objects into this node, and then we can use a weight value up here to blend between things. Again, it's a useful node, but a lot of these features you could also write in Vex. So in this case, I don't tend to use them too often. When I need to do one of these features, I tend to use Vex personally. Once you get to this level, that's where I would go. The next we have this one, and this is about precision on attributes. Again, not something to go too deep into, but it's good to know. Each attribute has a precision, and by default Houdini will try to write it out by auto based on your needs. And the precision just basically means the amount of memory that particular bit of data is going to take. Now attributes don't tend to take much memory unless you have a ton of them on a large set of geometry, in which case you can actually reduce the amount of precision the attribute has. If you're writing out to an integer, you might want to write it out to 8-bit. And I just noticed Houdini crashed, so maybe you don't want to do that. Give me one moment, then I restart my session. Okay, so I just had a crash. Not the best thing to do, but let's go ahead and recover the file. It's a bit of an impromptu little bit of the lecture. What I can do is I can go to my folder here, go to the temp folder, and here you will find all the recent crashed files. So here what I can do is go to my attribute example file, which was created just now, and let's go ahead and load this one. Okay, so it seems to have recovered my file. And now I can go ahead and save it back out to the original location if I want to, because we're currently working inside of our crash file. But I'm not going to do this for now. I'm just going to continue where I left off. So like I said, we could promote this value to an 8-bit value, but by doing so, we might not have enough range on this value for higher numbers, right? Because 8-bit has limitations on how far it can go. I don't know that from the top of my head, but anyway. If we use the attribute cast node here, we can actually take any attribute and remap it to another value. So this one actually remaps it to a 16-bit float instead. Turning it from an 8-bit integer to a 16-bit float might not be the best thing to do, but it's possible. So you can do that with this node. Now further down below, I just want to quickly go over a couple of the Vex script examples. We'll cover Vex script more during the course, and especially in the later modules of the course. But here's a couple of nodes that might be useful to you. Vex is written both in a node language and in a script language. And this node here, the attribute VOP, allows us to write code using nodes, right? Inside the Vex context. Now, in this particular case, I have taken the point position from my mesh, which is generated with a grid and a mountain node. And I'm splitting out the different position coordinates, and I'm doing different things with them. So the top one here, I am simply adding a value, and I'm running it through a random node, and this is applied to the red channel. As you can see, I'm moving the red channel around. Then the middle one, I'm simply multiplying it, so I can brighten up the green channel or remove it pretty much altogether. And then the bottom one takes the position in both the positive and negative coordinate and flips it into a positive channel regardless. So we can see how there are no negative channels in this one. It's all positive. So it only goes from black to blue either side. And then we merge it all back together at the end into the color channel. So we have several nodes here. This is how it was written, but we can also do this with Vex. Vex script, to be precise. And the easier way to do this is by using a attribute expression node. The attribute expression node allows us to use a couple of very simple expressions in this field to manipulate a set of attributes on our geometry. It's the simple version of using Vex scripting. Now here right now I am using the current point position. I'm applying this to a point attribute, but I could also apply this to, say, the color. And then it says self, which is its own attribute, so in this case the color value. And then I am applying a value to it, so this value here. So if I start manipulating these parameters, you can see how I am adding and removing colors to each of these channels. Or if I apply it to the point position, I can apply it like so. So that's pretty useful. And we can do this to multiple attributes at the same time. So if I apply this to color and this one to the normals, then we could potentially say plus the value, and we can start messing with the normals on this sphere. If you don't quite know what I'm doing, I'm basically changing the normal direction on this object, and this changes the way how it renders with my lighting, right? Alright, so the next one here is an attribute wrangle. And the attribute wrangle, unlike the attribute expression node, allows us to write Vex code in its entirety. And we can write a lot more complex scripts in here. Even so, it's probably one of the more faster ways to write Vex in Houdini, because unlike the attribute VOP, you don't have to worry about adding lots of nodes together. You can just add a simple line. Now in this case, what I have here is the vector attribute P, which is the point position, and it's being added to by the normal, and that's then being multiplied by a channel reference for a float parameter down here. So in this case, if I change this float parameter around, then the sphere expands or contracts based on the normals on the sphere. Now this is very similar to, say, the peak node that we had up top right here, which also allowed us to do the same thing. But this allows us to do it in Vex, and we can add other pieces of code to it as well. So let's say we want to add a color to this sphere. Well, in that case we need to access the color attribute, which is also a vector. So I'm going to add the prefix v, then I'm going to type cd for the color attribute, and you don't have to add the v prefix, it will work without, but it just makes it a bit more secure. Likewise, there's other prefixes as well, such as f for float, y for integers, and s for strings. And if we type this, then by default Houdini will already access this attribute. And if I simply add a terminator at the end of the line right here, then you can see that it's actually added a color attribute, and it's populated it with its default attribute values for color, which is white. Now what I can do is go in here and add a reference for say a color parameter. So I'm going to say equals a channel vector expression, and let's reference a new parameter called setColor. Now this won't do anything yet because we still need to create the parameter, and right now this node is trying to access a parameter on its own interface because we're not navigating up the network like so. So if we want to do that, we can create one right over here on the right, if we click this button, we will create a new spare parameter that's unique for every parameter that hasn't been set yet on the node. If we click this, we actually create a new parameter specifically for our color. So that's all working fine. Let's set this to something like 0.5, 0.25. Okay. And next, let's go ahead and bind it to our expansion value. So this parameter here. And we can either type it in or we can copy our code up here. Let's do that. Let's add it in between. And now, if we shrink our sphere or we expand it, we actually increase the brightness of the color as well. So as you can see, we can quickly write some more intricate pieces of script. This can go way further. We'll go much further than this inside the main master class, inside of our future lectures. We'll cover a little bit of it during the foundation module, but we'll cover a lot of it in the upcoming modules. So don't worry about that, we'll get to it. And there's one last thing that I quickly want to show you about Vex before we continue, and that is that if you have an attribute VOP, it actually contains Vex code inside of it. The nodes that we have inside of an attribute VOP actually write out Vex code whenever we plug them in. So if I right click on the attribute VOP node and I go to Vex VOP options, we can view the Vex code of this node. And this will allow me to see every single function that was set up and all the variables inside of it. Now there's way too many variables here than we actually need, but it's necessary to make this attribute VOP work, so this is just what we get. But if we look down the bottom of the code, we can find a lot of the nodes that we actually called inside of our attribute VOP node. So down here we have the absolute function, which again takes any negative value and makes it positive. And here inside the Vex code, it's actually being called right there. Likewise, we can also find the random functions right up here. So if you ever want to learn how to create something in Vex script and you know how to do it in VOP nodes, then you can retrieve it like this. Also, of course, you can also access the help file. So if we go to a Wrangle node and we click on the help card, then you will find a lot of Vex scripts. So if I go down the list, there are a couple of examples here. And then if we look for specifically Vex scripts, and maybe we need to actually look for a particular function. So let's say we look for the round to integer function. Then we can find all kinds of nodes that have a similar naming convention right here. So in this case, the round to integer function just takes any value and rounds it to its nearest number. So yeah, you can find a lot of the code right here. If you want to learn Vex, then I suggest you start by reading through the help file and just get yourself familiar with some of the Vex functions that you can find inside Vex, because there are a lot of them. Okay, so at this point I think we're done with this video. We've explored quite a few attribute related SOP nodes and how they can be used. And we've also had a little look at Vex specifically. So with that, I'll see you in the next video. We'll be looking into groups more closely. And have a good one.